All right, ladies and gentlemen, so these are your electric circuit notes. I would like for you to take these notes in your journals if you have them. I know we haven't used them in a little while, so if you can't find them, that's okay. You can take these notes on a Google Doc. All right, excuse me. All right, so the first thing we want to talk about, we talked about this quite a bit already, but how electricity moves. So electricity moves through a closed pathway that we call a circuit. And a circuit's just a pathway. You'll hear that word circuit used in other ways too. But a circuit is a pathway. Now, for the electricity to flow, the circuit has to be closed. If it's closed, it has no breaks and no openings. So the path is complete to and from the power source. So in our image, we have the electricity flowing from the battery along the wire to the light bulb through the switch that is closed and then back to the battery. So it has to have a complete path from start to finish to the power source. Go ahead and write everything that you see on the screen in your notes. You do not have to draw the picture if you don't want to, but it would be helpful. Pause the video if you need to. All right, so we looked at a couple of different types of circuits yesterday, and so I want to make sure we understand the difference between a series circuit or a parallel circuit. So a series circuit, that's the simplest kind of circuit. So an electric circuit is a simple path with only one way through. Then we call it a series circuit. So you can see in the image below we have our battery. We have two light bulbs, but there's just one pathway that the electricity can travel through from start to finish. So we call that a series circuit. Go ahead and write what you see on the screen in your notes. You may draw the picture if you want to, but you don't have to. So a parallel circuit is a little bit different because a parallel circuit has more than one path, and it can have many paths. It can have, in the case of this picture, it has two paths where we have the first path where light bulb 1 will be lit up, and then the second path where we have the switch in light bulb 2 where we can control whether or not light bulb 2 comes on or off. And we call these parallel circuits. And again, this parallel circuit only has two parallel circuits, but you can add, as we saw yesterday, you can add 3 or 4 or 5, or as many as your power source can handle. But we call these parallel circuits. Go and write this down in your notes. Pause the video if you need to. You may draw the picture if you would like, but you don't have to. The last thing I want you to put in your notes is an idea that we talked about quite a bit last week, but I want to make sure that we really drive the point home this week as we're looking at electric circuits. And that's this idea that electric circuits can produce our other energy types. They can produce mechanical energy, like the little toy motor that's pictured on the bottom left, or they can produce light with light bulbs like we were doing, or they can produce heat if we run them through a heater, like the heater that's pictured, or they can produce sound energy, like the buzzer that is down on the bottom right. That's what that little black plastic looking thing is. It's a buzzer. But just this idea that that electric circuits can produce mechanical energy, light energy, heat energy, or sound energy. So go ahead and copy this down in your notes. And when you have finished that, you have completed your notes for this week.